All right, guys. 6.2 is a very both useful and tedious section. Lucky for us with Statcrunch, it's pretty straightforward. And in fact, even if we didn't have Statcrunch, it's really not too bad a calculation to do by hand. So um, let's just jump in. Where is this? Okay. So let's go here. I'll try to explain in my own words what binomial probability is. It's basically when you have a number of events being performed, a set number, one, two, three, four, five. You're going to try an experiment over and over. And each time has the same likely probability, such as flipping a coin or maybe it raining. There's a formula, and the formula is called binomial probability. And we can just calculate the probability of something happening. Okay, so what's going on here is we have 10 experiments performed. So we try this experiment 10 times. P represents, it's called probability of success. You can see that the probability of failure would be 1 minus that. And X is, what X means is quite simple. It's the probability that the thing is successful 8 times out of 10. So out of 10 times, what's the probability that this thing happens correctly? Exactly 8. Well, think about it. What would we expect? If each event has a 45% likelihood, it's not going to be too likely that 8 out of 10 are all success. So we can simply open Statcrunch. So go to get more help, Statcrunch. And as you can expect, you guys should be at this point in the class where you kind of know where you could find this calculator. We go stat calculators binomial. Okay. So we get to see a new one. We tell it n is 10. That's already there. We change p to 0.45. And we want to know the probability of 8 successes. So we change this to equals. And change that to 8. And then hit compute. And so you can see it's very, very, very unlikely. It's about a 2% chance. But right here is the answer. Okay. Next question's the same exact thing, just different numbers. So this time we have n is 5. We have p is 0.4. And we want to calculate the probability that's exactly 2. Okay, so this is going to be more likely because there's not as many successes we're measuring. Okay, and then we get our probability is 34%. So that means there's a 34% chance that out of 5 experiments, 2 will be successes. Okay, that's it. That's really binomial. So this one, we just have to point this out. Just change this thing to less than or equal to, and then enter the information, okay? So enter n is 9 and so on. Again, same thing, just change the less than or equal to less than. So that's going to look like this. That. And this one, change it back to less than or equal to. Okay, so you can kind of see the pattern to getting these. This one looks crazy, but all you would do, it's just going to be a multiple calculation. So n is always going to be 6. Probability is always going to be 0.15. And then for each one, oh, where'd you go? Where'd that go? Sorry, this thing's not closing. I don't know. I can't see it. Oh, come on. I have to close this. Oh, there we go. So change this to equal. And for each one, just do 0. Write that probability down. 1. Write that probably. 2, 3. And you can see they're decreasing. 4. And so for each box, you fill that in. Okay. I want you guys to try a little bit more, so I'll let you guys try that one, but it's obviously it's going to be built off all of these. Okay. So this one is just probably binomial again. So this one looks a little hard, but I want you guys to try that because I don't want these videos just to be like, here's how you do the homework. I want you guys to really like deep dive into these. Um, okay, same thing. And same thing. So these were more applied. Just expect that you're using the binomial probability calculator. And that should be it. So these should be gone. I don't know why these are still here, but all right, guys. So that's it for 6-2. Yeah, I hope that helps. Good luck.